microprocessor based control system, microcontroller based control system. Okay. Now, first of all, we should know what is microprocessor. Okay. What is microprocessor? Okay. In automation, we are using relay logic. So after the relay logic, they started to develop an automation using the microprocessor. Okay. Then from the after that means after microprocessor, and there is a development in the automation system, or especially we can say development in the digital processor. Okay, and they start to develop a compact device, so that is called the microcontroller. Fine. So what the difference between microprocessor and microcontroller? First of all, we should know what is microprocessor. So microprocessor, we can say this is basically CPU. Okay, basically CPU. Fine. So one more thing we can say. Okay, one more thing we can say about the microprocessor, or we can define the microprocessor in a different way. Okay, microprocessor may be combination of ALU, okay, internal registers, okay, and clock. Okay. So ALU is for what purpose? To do some mathematical process, or to solve them electrical, okay, process. What is meant by what the full form of the ALU? Arithmetical logic unit. So by the name itself, we can say what the process will happen inside it. Okay. Now whatever you do the process, you have to give some input. So where will you give that input? That you will give input from the register to ALU. Isn't it? Similarly, after doing the process, you have to save the result. So where will you save the result? Again, you will try to bring the result into the register. So that's why we require basically registers to hold the data. Okay, and the data we are giving to the ALU, we will try to process according to the requirement. Then result of the process will be again stored in the register. Fine. Now, the moving the data from register to ALU to register, are moving somewhere out of that microprocessor. What will you do? So for the purpose, we are using the clock. Okay, for the purpose only we are using the clock. Okay, there is a clock system inside the microprocessor. You might have seen, crystal frequency. You might have heard about the crystal frequency. Okay, so basically that crystal will help to generate the clock, and the clock will try to trigger the digital system. You might have heard about the shift registers. So shift register will help you to move the data from one place to another place. So how that shift register will move the data from one place to another place? By giving the clock. So from where will you get the clock? There will be a separate clock circuit in the microprocessor. Okay, like that. So to transfer the data from outside of the microprocessor, we need some communication port. Okay, so it can be like a parallel port or serial port. You might have heard about it, UART. So where you used to transfer the data in series. Like that, you might have seen in the microprocessor, there is a data pin D0 to D7. Okay, so that's also used to transfer the data from one place to another place. Then you might have seen the address pins A0 to A15 in 8085. Okay, so like that. So address pins are to get the particular data from the particular register. So how will you address it? So that addressing is defined with help of the address pin. Okay, once you define the address, then automatically you will try to locate that position of the register. Then you will take the data and wherever you want, there you can push it. Okay, so that's the process. So basically what is inside the microprocessor? Inside the microprocessor, we have ALU, registers, clock, some communication ports. Fine. Now there is no memory in the microprocessor. You might have heard about it. Okay. So if you want to use some memory, okay, to store the program, then we have to use externally. Similarly, while processing itself, if there is any temporary storage of result, then you may require RAM. So that's also you have to use externally in the microprocessor. Okay, then if you want to do some setup of controlling, like a relay, and connecting some inputs like a switches, okay, then we require a port. That port also not available in the microprocessor. You might have heard about it. A chip is called 8255 PPI. Okay, so that PPI is a external device which will help to develop some controlling, okay, controlling system or control system with help of the microprocessor. So like that, we can see here in the block diagram, microprocessor based, okay, block diagram. Here you can see this is the microprocessor. There is no inside the memory. We have to connect memory, whether it is, okay, program memory or it may be data memory. That should be connected externally. Then if you want a port, we should connect the port like this. So already I told, if you want to connect any input devices, that should be connected through the, okay, connected through the port. Similarly, if you want to connect any output device, that should be connected through the port. Okay, so this is about the microprocessor. So it means what? Basically, other than the microprocessor, you have to add more number of devices externally. Then automatically what will happen? The complexity of the circuit will increase. So it means what? You should have very good knowledge of, okay, electrical wiring, digital data transfer technology. That means what type of port and what type of, okay, what is say, we can program we can use it. Or you can say how the data frame is moved from one place to another place. Because you see in serial port, you might have heard about UART, you might have heard about IT square, I square C, you might have heard about SPI. These are serial communication only. But why we are giving different name? Because we have to move from one place to another place. We may use bicycle, we may use bike, we may use car, we may use train. Like that, okay. So there are different protocols are there for different types of communication. So if you are familiar with that protocols, then it is easy to handle and easy to access the thing. So that is called the embedded system. Okay, that comes in the embedded system. So here we are talking about the automation. Okay, so we are not worried about that things. Okay, so but we should know basic knowledge about the how an automation system can be developed with help of the microprocessor. Okay, so any doubt? Any doubt about the microprocessor based? Okay, now after that we got microcontroller. So that means people have started to develop, okay, a compact device which can have, okay, inbuilt microprocessor plus PPI. Okay, programmable peripheral devices plus, okay, microprocessor. Both you can combine and make it as a single chip. So that is called the, okay, microcontroller. So in the microcontroller you can directly connect input and output devices. How? Let us see here. Okay, so you might have seen in the Arduino board basically what? Inside they are using the microcontroller. If you want to interface switch, you can directly interface it. There is no need of separate port. Okay, so like that we can connect input devices, we can connect output devices, and output devices are operating by the 5 volt, you can directly connect it. Like what we saw the previously, okay, the microwave oven need 230 volt. Okay, so you can't connect that microwave oven directly to the microcontroller. So it means what? You have to connect a relay between microcontroller and microwave oven. Okay, so like that you can see here a relay and heater. And this relay should be controlled by the microcontroller. So automatically what happened? Your complexity, okay, is come down. Okay, it came down. Okay, so then programming more or less like a microprocessor only. Okay, programming like a microprocessor only. But in microprocessor, they were using assembly language. In microcontroller, they start to use the this C-based type programming also. Okay, so that is one more advantage. Okay, like that. Okay, this is a microcontroller-based control system. Now, you can say what is the difference between microprocessor and microcontroller-based automation system? Can you define your own? One is you can say the complexity is less in the microcontroller and complexity is more in the microprocessor. Okay, then if there is any fault comes, okay, it is easy to detect in the microcontroller and it is difficult to detect in the microprocessor system. Okay, and microprocessor system can be used for very large control also because we are adding memory externally. How much memory you want, you can add externally. So you can put a program, very big program also. But in microcontroller, there is an inbuilt memory. So how much memory is inside the microcontroller? Based on that only, you have to design your automation system. Okay? Like that. Okay? Then price wise, okay, since you are connecting most of the devices external to the microprocessor, obviously the price may be more with the microprocessor system. Okay, since it is very compact microcontroller, the price of automation system may be less. Okay, but when you talk about the complexity of automation, okay, for example, in laptop or desktop, we are using microprocessor. So can we use this laptop and desktop for automation or not? Can we use the laptop for automation or not? We can use it. Because you say a laptop can be used along with the flight controller. Okay, a laptop can be used, okay, simply to control a relay also by adding some external device. Okay, so if it is microprocessor based system, obviously we can control very complex automation system also. Okay, but with help of microcontroller, we can use only small automation system. Like microcontrollers are used like a air conditioning, washing machine, microwave oven, like that purpose they are using the, generally they use the for portable system. If the system is very portable, they will use the microcontroller. Okay, the system is automation is big and it's not there is no portable, then they will try to use like a microprocessor, because with the help of the microprocessor you can solve very complex problem. So that is the advantage. So anything about the microprocessor, microcontroller? Doubt?